വിരലറിയാതെ കൊണ്ടതാ. ഇതെടുക്കുക.
Very good morning, one and all. So we are just going to initiate the inaugural function of this FTP very soon, and it will be started as per the schedule. Means by 11 a.m. onwards, it will be started. So please.
Yeah, people have started joining. Shall I make it mute?
Yes, so you mute it first. You just see beneath the screen, right? There's a series of buttons. Mute.
Hello, sir. Hello.
Record.
Hello, yes. Good morning.
Yes, warm welcome, sir. Very good morning.
Good morning. Good morning. Give me a little time, please. Yeah.
Yeah, please, sir. Actually, our participants are joining, so I will let you know, please, sir.
Yeah.
We can have
okay.
we can wait for a few minutes, sir. Please.
Yeah.
Okay, sir.
Hello, sir.
Yeah. So.
Do you see a share button?
Share.
On the yeah.
Yeah.
Do you see that? Is that
Share.
button?
Yeah.
You click on share. Yes, you click on share, and then you share your whole screen. If possible, share whole screen.
Share whole screen.
Yeah, correct.
Share. Refresh frame. Share the view source. Share frame. Frame source. Share frame. Is it?
Yeah, share, correct. You just share.
Share. No, share takes me to share with Facebook, Twitter. So not this, correct?
Wait, next share. It should be the one because share screen. Wait, share.
Share. Share. Share content. Share.
Okay, let me see. When you click on share, right, you should see what should you see? Share content. Share content. Can you share content?
How do I come out? Cancel. Cancel.
Share full screen. Yeah, share full screen.
Where?
Can you share a full screen?
Share gives me share. Then share content.
Yeah, share content. Correct. Yes, sir. Share content.
Share
देन हे करा.
Okay. Leon?
Yeah. Yeah. Hello. Can you hear me?
Yeah, I can hear you. Yeah.
Professor Mustafizur Rahman sir.
थोड़ी देर का होगा, कोई नहीं।
Give me the. Sir, kindly
अच्छा।
unmute. रवि, प्रोफेसर मुस्तफिजुर रहमान सर का अनम्यूट नहीं हुआ हुआ है शायद माइक।
मैं देखता हूँ सर, आई एम जस्ट गोइंग थ्रू।
वीडियो
सर।
बंद हो गया क्या? नहीं सर, ये शटर हो।
Yeah, and I open the video also.
Yeah, open the video.
Why it doesn't open?
Rahman sir, your voice is very clear, but
Yeah, but
Yeah, you can-
video option use.
yeah,
No,
now
no, video is coming, sir. Your video is
it
coming.
is coming,
Okay.
coming
It is
soon.
visible.
Yeah,
Yeah. Now
But
both
on
of
my
things,
screen, on
your
my
voice
screen,
is
I
also
cannot see
clear,
my
sir.
own screen.
no issue, sir. Actually, we are just starting the inaugural. Later on, your screen will be required, actually. No
I
issue.
see. Okay, let
Yeah.
me. Okay, I hope it will be. Okay, then. Yeah.
Yeah, so a very good morning, you all. I, on the behalf of organizing committee, welcome all the participants from the different places, institutions around the country. So in this event from almost 27 states of India has been covered to attend this AICT ATAL sponsored 6 days online FDP on 3D printing for biomedical applications, shaping the future of healthcare in the era of Industry 4.0. So we are really very glad to have such a huge response throughout. So in order to initiate the inaugural ceremony, first and foremost, we are highly grateful and thankful to our worthy director for his entire support to organize this FDP. Thank you so much, sir. We are also thankful to Professor Mustafizur Rahman, NUS Singapore, for accepting our invitation and being here as a guest of honor in today's inaugural function. We are highly thankful for your valuable time, sir. Thank you so much. We are also grateful to Professor Hari Singh, sir, Head of the Department, Mechanical Engineering, for supporting us whenever and wherever needed to conduct this FDP. We are grateful to our participants as well as the faculty colleague organizing team, Professor Rathi, Professor Pankaj, Dinesh sir, Professor Rajneesh Singhal sir, to entirely support during the organization of this FDP as well as to motivate us. Thank you all. So now I would like to request Professor Sandeep Singhal, the coordinator of this online FDP, to give an overview about the program. Sir, hand over to you, please.
Thank you, Professor Ravi. And it's a pleasure that you got such a large number of participants. I hope it is more than 600 participants, comprising of the entire India. That means pan-India participation is there. First of all, I would like to place my gratitude to the director, Professor B.V. Ramana Reddy sir, our head of the department, Professor Hari Singh sir, Professor Rahman sir, who has taken all the pains to join in this 3D printing FDP program from NUS Singapore. I would like to place my gratitude to the entire team, organizing team, including Professor Ravi Pratap Singh, Professor Rathi, Professor Dinesh, so that this program becomes successful. Now, giving an overview regarding this 3D printing. See, 3D printing technology is one of the new innovations which emerged into the recent times. And at present, it is being used into n number of industries, be it the aviation industry, be it the medical industry, be it the manufacturing industry. I would like to say that 3D printing is becoming a milestone into this manufacturing process. 3D printing or additive manufacturing or layered manufacturing, as we say, this is now becoming much adaptable because of its ease and because of its ability to address the complexity of the manufacturing processes. Regarding this biomedical applications, 3D printing is being used into surgery, it is being used into pharmaceutical industry, it is being into disease modeling, it is being used for customized implants, be it the dental implants or be it other sort of implants into the body. It is being used for organ printing. It is being used for some prosthesis. Even this can be used for manufacture or for applying for artificial sort of skills. So there are a lot of use, and our life will definitely change in this era of uncertainty because of 3D printing in medical applications. Our life will become easy, and the people who have been suffering with the major diseases, especially the disease like cancer. Cancer, it is 3D printing is going to be a miracle for diagnosis and for treatment of cancer. In this 3D printing, we use normally a CAD software and a lot of other sort of technologies such as layers or stereolitho technologies and other things are there. So within this next 6 days, all the participants will be learning a lot onto all these new technologies and all these new applications. I would like to now thank Professor Rajneesh, Professor Mustafizur Rahman, who will be taking a class on advances in additive manufacturing process. Shri Piyush D. Uke, who is the director New OSA Medical Equipments, Maharashtra, will be giving an overview on 3D printing opportunities in healthcare sector. Dr. Sandeep Dhake, founder Precision Research India Private Limited, Nagpur. He will be giving an overview on custom surgical guides using 3D printing. Then Shri Abhijit Rao, he will be giving an overview on biomedical device development. Professor Narendra Kumar from NIT Jalandhar, he will be discussing about CAD modeling and STL editing. Then Professor Mohit Tyagi, who will be giving on STM aspects in 3D printing.
Welcome to Webex.
Then Professor A.M. Kuthe, he will be giving overview on medical prototyping, rapid prototyping. Abhijit Rao, ABCD of 3D printing. He is the founder of Nandini Foundations, Nagpur. Professor Ramesh Singh from University of Malaysia, University of Malaya, Malaysia. Advanced processing of bioceramics. Then Professor Ravi Pratap Singh, he will be discussing about the aspects of 4D printing for biomedical applications. Now there will be a change there from 3D printing to 4D printing again. Then Professor design of 3D printing.
The video to you. You look at the video. The video show you how ability to
all these experts, all these experienced professionals, I hope and I'm sure enough that all the participants will be value added after these 6 days into 3D printing and its application into biomedical applications. Back to Ravi.
Thank you so much, sir, for this detailed overview about the FDP and shared with our participants. Now I would like to request our chief guest of today, Professor Hari Singh, sir, head of the department. Sir, I request you to please share your words of wisdom with our participants. So please.
Thank you, Dr. Ravi. Am I?
Yes, sir.
Hello. Okay.
Yes, sir. You
So
are
very
audible,
good
sir.
morning to. Okay. Thank you, Dr. Singhal. Very good morning to one and all. The coordinator of this FDP, ATAL FDP, on 3D printing for biomedical applications, shaping future of healthcare in 4.0. So the coordinator of this program, Dr. Sandeep Singhal, co-coordinator, Dr. Ravi Pratap Singh, and other faculty member, joint co-coordinators, Dr. Rajneesh, Dr. Rajiv Rathi, Dr. Pankaj, Dr. Dinesh Rathod, other faculty members of the department, outside the department, all the external experts, including Professor Rahman from NUS and other experts, and my dear participants. So I am delighted to share that in the beginning of the new year 2025, the department is taking a lead in a way in conducting a program on very important topic 3D printing for biomedical applications. As you are aware that healthcare that plays I think the most important role in everyone's life. So it's a very good idea that we should become conversant with the problems, with the challenges related to the healthcare industry, and particularly in the modern era when we talk about industry 4.0, kind of fourth industrial revolution, where there is a mix of, as we understand, all the good hi-fi technologies, including artificial intelligence, IoT, and other are coupled within. So there are numerous applications in the healthcare industry of this 3D printing, in particular, if you talk about additive manufacturing. So experts will be highlighting, as Professor Sandeep Singhal was pointing out, that we have a number of experts available to talk about the various issues. But it is very important to point out that in the healthcare sector, the utmost importance is to be given to the precision, accuracy. There is no scope for sort of allowance, like say we talk about in the say physical parts, physical world, industrial components. So say, for example, some artificial limb is to be inserted in human being. So obviously that has to meet all the requirements, so that is fulfilled through customized sort of production of such components through 3D printing. So that is feasible through this. So with the given advanced technologies, now say we are in a position to manufacture such say precise parts, we should say 100% accurate parts, nothing like say 99% like that, we talk about 100% say. So that fits absolutely perfect wherever it is needed. So without taking much time, so I wish this 6 days program 13 to 18 January a grand success, and hope that all the participants will be highly benefited to the delivery of the expert lecture from various experts. So thank you so much.
Thank you so much, sir, for your motivational words and the overview about the FDP theme. Thank you so much for your valuable time and kind words. Now I would like to request our guest of the honor, Professor Mustafizur Rahman, sir, to say some words to our participants and motivate them. Please, sir.
Okay, can you hear me?
Yeah, please, sir. Audible.
Yes, sir,
Okay.
please.
Yeah, good morning to all. Yes, really I'm honored that you have invited me to give a talk. And as I was talking to Professor Ravi, that my whole life is on machining. Why I should be talking about 3D printing? How can I dare to do that? And he said, no, you can do it. Think about it, prepare a talk some. And then I thought, okay, I'll try my best. And then what I feel is that definitely the topic you have chosen is very much needed to be discussed. And it is growing so fast, and it's a blessing that it came in time. And definitely, everybody knows that 3D printing has brought a new direction in manufacturing. Manufacturing reached almost to its throat. It could not think of anything more. Everything was done by machining. 3D printing has really accelerated manufacturing. It has reduced the time of manufacturing. So today I'll be talking about how the manufacturing by 3D printing and manufacturing by machining can complement each other. And to the young people of India, those who are in research, they have definitely chosen a topic. This topic we should really seriously take it up. Now, when I mean by seriously take it up, a good research needs a lot of good thinking. It is not doing an experiment. I'm trying to tell to the young people, not to the old generation, young people, because I'm sharing my experience of examining the thesis of Indian students. Please accept it as a suggestion and appreciation, not as a criticism. And research, I feel, should be something. It is not an experiment. It is searching, research. It is searching and researching. Searching what? Searching something which is new. Searching something which is beneficial. Searching something which is relevant. So every research topic of PhD or master's should be looking for something new, something relevant, something useful. It should not be a continuation of some work. Even if it is a continuation of some work, it should have a significant breakthrough to make a big difference. For instance, if someone does research on making something new using one material, somebody does on another material, and so on, contribution is not very significant. So you have to think of something which is a topic of PhD, Doctor of Philosophy. Your philosophy should be in it to claim that, yes, I've done something new. That is my request. So now coming to 3D printing, all of us, I mean, those who are manufacturing and taken up 3D printing as a topic of research, my honest request would be to do something new, something like breakthrough. And today, as manufacturing using 3D printing has reached to a very high level, but when it comes to accuracy, surface finish, and so on, there is a serious bottleneck. 3D printing has a limit of achieving that accuracy and surface finish. Why I'm mentioning that, and especially today in this seminar, it will be 3D printing for biomedical application. And biomedical application, if you want to use 3D printed object, there should not be any compromise. And I'll try to touch on some of the points in my presentation. So then I request young researchers to look for new topics around this area to make it really biocompatible, really a product which body will take it easily without any resistance, and what it should be. I do not have the ready answer. Some of the points I'll be discussing, but take it up from that point. Not that I've done a project on 3D printing, but it should be a significant breakthrough. People will be benefited out of that, and it should be a real research, not a continuation of another research, which is just me too. So this is my thinking and request to all young researchers to take research more seriously, looking for a breakthrough. I think I would like to end up here.
Yeah.
Thank you so much for listening.
Thank you. Thank you so much, sir, for your words of wisdom and this much of discussion about the theme of this FDP event. We are highly delighted to have you here, sir. Thank you for your valuable time. Thank you. So now I would like to invite Dr. Rajneesh, sir, to present vote of thanks so that we can conclude this inaugural ceremony.
Thank you, Dr. Ravi. Am I audible?
Yeah, please.
Okay. So first of all, thank you for inviting me to present this vote of thanks. Respected dignitaries, esteemed faculty members, dear participants, ladies and gentlemen. On the occasion of inaugural ceremony of this enriching online FDP on 3D printing of biomedical applications, shaping the future of healthcare in Industry 4.0, it gives me great pleasure and profound sense of gratitude to extend my heartfelt thanks to everyone who has contributed to the successfully planned and execution of this AICT-sponsored FDP. I, on behalf of organizing committee, I would like to express my sincere gratitude to all the dignitaries who graced us with their presence and made this occasion a grand success. We are deeply honored to have our esteemed guest of honor, Professor Mustafizur Rahman from National University of Singapore among us. We are grateful for the inspiring words shared by you, sir, and providing us with your precious insights on the importance of emerging technologies like 3D printing in the present scenario of fourth industrial revolution. We are thankful to the head of the Department of Mechanical Engineering Department, Professor Hari Singh, for his motivational words to the participants. I would like to express our deepest gratitude to our esteemed speakers for generously sharing their knowledge, insights, and expertise with us. I would also like to extend our sincere appreciations to all the participants who have actively participated for the inauguration session. Finally, I would like to thank the organizing committee for their meticulous planning, coordination, and execution of this 1 week online FDP. Your hard work and dedication has been instrumental in ensuring the smooth conduct of the sessions and the overall success of the event. At the end, dear participants, we hope that you all will have a great learning and fruitful discussion with our learned experts during these 6 days. Thank you once again. Thank you all. Over to Dr. Ravi, please.
Thank you so much, sir, for presenting vote of thanks. So, dear participants, we are here concluding the inaugural ceremony of this FDP, and the very first session will be started in a couple of minutes. Professor Mustafizur Rahman sir will discuss with you about the beliefs, what is the 3D printing, how it is related with the machining, and how the machining is more important with that. So soon it will be started. So be here, and Professor Rahman sir will be presenting his first session. Thank you so much. Thank you.
I
Yeah, Rahman sir.
yes.
Yeah.
Just give me a second. I have
Yeah,
some
please.
technical problem. I cannot see the whole screen, and
What your screen from your side is visible. I think a simple
I
white
see.
screen is coming now.
Okay, then I need to see how do I share my screen.
Okay, sir, no issue. Take your time, sir, please. Yeah, it is visible now, sir. Make it on full screen if possible there.
Yeah, that's the problem I'm facing. I'm sharing the screen, but the correct screen is not here. Yeah, this is the screen. Then how do I just let me give a call to my.
Yeah, please,
I'm
please.
overseas now. I'm in Bangladesh, so I'm not in Singapore. I'm not getting help from my colleague.
No issue, sir, please take.
Just give me a second. You can see the whole screen?
Yeah, whole screen is coming, but yeah, separate slides are not coming as it is in a minimized form, I think.
And
Simple.
yeah, minimized form.
Yeah.
So, Wayong, yeah. So shall I open the screen, the presentation again?
Yeah, correct. Yeah, you open the PowerPoint slide.
I opened the screen, yeah, PowerPoint slide, and
Then now you go to X, you share your screen.
WebEx. That WebEx, I cannot see the whole screen.
You cannot see the whole screen. Is it minimized somewhere? You check whether you have anything, any small window down there that's open. That's why you cannot see.
Yeah, I don't know why.
Okay, so in this case, what we do,
Yeah.
we lock out again, we lock in again. Otherwise, you cannot find the screen. You tell them that you are going to lock out and you lock in again.
Yeah, Prof. Ravi. Hello, Prof. Ravi. Hello.
Yes, sir.
Can
Yes, sir.
you hear me? You
Sandeep
can hear
Singhal,
me.
sir.
Okay. Just I log out once and log in again.
Yeah, sure do. Kindly
Yeah.
do that, sir.
Yeah. So I go back to.
You log out first. Once you log out, you close all the X and then you go to a link again, you start from fresh. Then everything back on.
That how do I log out? So minimize the screen. This I go to my link.
So one thing I can do, sir, can you on your WhatsApp video call, you show me your screen. I have to see what is happening.
So let me open the link again.
Yeah, you open the link again, correct?
Just give me a second.
Yeah.
Can you see the video?
Wait, I'm trying to see. Okay, now I'm trying to see your screen. Okay, let me see. Sir.
Open.
Can you push straight?
So join from a browser, correct?
Yes, sir. Don't forget. Yeah. So I can't see your screen properly. Can you bring your handphone down a little bit? Yeah. Okay, yeah, good. Bring down, lower your. Yes, correct. Okay, now I see. Let me see what is that.
Join as a guest, huh?
Yes, sir. Yeah, correct. Join as a guest, correct.
Mustafa Rahman next, huh?
Yeah, next, correct.
Yeah, it is rotating and rotating. I don't know why.
Yeah, it's loading. You have closed all other windows, right? There's no other window, right? This is the only one, right?
Any
Yeah.
desk also shall I close?
So any desk, close it. Close any desk. Yeah, close any desk. You minimize first, you go close any desk.
Shall I click join meeting?
Yeah, join meeting.
Connecting. Yeah, I can see that.
Sir, can you bring your handphone down? Face it down.
Sorry.
Go lower. Okay, from here, right? I can see that. Can you click on share?
Share, yeah. Then click share, huh?
Correct. Yes, correct. Yeah, click share.
But I see the screen.
Okay, wait, let me see. So can you see properly?
Sorry.
Yeah, this is it. We see. Okay. You share. Go to entire window. Screen, third one. Entire screen.
This one. Entire screen, yeah.
Yes.
Yeah.
Yes. And then, okay. Can you bring your phone down? I cannot see the click button. Share. See on share.
It doesn't work. I don't know.
Okay, so you click on the screen. Can you see there's a screen there?
It doesn't go to the screen also.
Is this or what?
So share cannot.
It is you click on the screen, you see there's a screen. You see there's a screen there, right?
Yeah, background there is a screen.
Yeah, you click on the screen, double click on the screen.
Nothing happens.
Okay, double click on the screen and then you click share. Now you click share. On the share button.
No, it doesn't work. I need to come out of this screen.
So this is correct.
Okay.
You see again now. So you bring your mobile phone to the here. Okay, first thing first, you click on the you bring your you click your laptop to left. Yeah, let's see what I said. Can you click on the window appearing inside yeah, you click on that. Not happening. Okay. Click on the window. Not this window. Not this window. Inside the blue button here, right? Yeah. Okay, what you said. Okay, go to entire screen. Go to entire screen. Yeah. You click on you click on the black box.
Sorry, click on.
Can you click on the black box? The black box.
Which box? Sorry.
The black box. Just below the window, there's one box, right? There's one small photo. Can you see that?
Yes.
Yes, correct. Now you share that. Now you work.
Yeah.
Okay. Now you
Okay. PowerPoint slide.
you minimize the web.
Yeah, PowerPoint slide.
Yeah, open up. Okay. Then you put it into the mode.
Is not right. PowerPoint slide.
Below. PowerPoint slide. Why is the PowerPoint slide? Yeah.
Because there are so many open things.
Minimize the entire screen.
When I open it again. Yes, I open it. Yeah. Can you see my screen? Hello. Ravi. Ravi, can you see my screen? Ravi, can you hear me? Sorry. Okay. I cannot leave the meeting, right?
Now what happening?
I'm back to my screen of presentation. WebEx, agree. No, now in the meantime, let me try to delete also many files, correct?
Yeah, okay. Yeah, you have too many files. Delete them away.
Yeah. Delete. Oh, I don't know. So let
Now, are you inside? Are you still in WebEx?
join meeting, yeah.
Yeah, join meeting, correct. Join meeting now. Now you only have your PowerPoint slide and the WebEx only two windows, right? All closed already, right?
I hope, I don't know. If I go to PowerPoint slides, I
Oh.
see my screen, and if I minimize it, hopefully I don't see anything more. So
Yeah, then let's do it. Just now there's too many windows. That's why we are getting a
so
lot of
I go back to WebEx, join the meet.
Join meeting, yes. Now
Join.
we do everything again. We just share. Yeah.
No, but they are asking me to give the link, meeting number. So I better come out of this and go to my mail, correct?
Yeah, go to a mail. Yeah, use your mail to enter.
Open. Join as guest.
Yeah.
Next. I should have been in Singapore.
Yeah, I didn't know that why they use WebEx. I think you never used before. So that's
Yeah. Join meeting.
Yeah.
Oh, asking for meeting number or link. Why? I came from the.
Just how you log in, right?
Yeah.
Using the same link, you should be able to log in.
Yeah. So I look back to go to the mail for the link.
Yeah, go to the mail and then click on the link. It should directly bring you to whatever you need to go.
Or shall I copy this link and go there?
Also you can do that.
Invalid meeting link.
Hello, sir.
Yes,
You are
it
already in meeting,
shows
sir.
me.
Sir, you
I'm
already
in.
You are already in. Yes, sir. Your voice is
Okay,
visible
let
and
me
your
then.
slide is also visible.
Okay, so I don't need this link again.
Yes, sir. Don't need to join again.
I see. Okay, then where am I?
Can you see the web? Can you see the web screen that is showing the meeting?
So your screen is visible, sir. You can directly present
Where
it.
should I click to? No. Where do I go back? How do I go back to the meeting?
Do you go to internet browser? Can you see the WebEx tab over there?
Oh no.
Sir, just go to the PowerPoint and start presentation. You are already visible.
Sir, you are already
Okay.
visible on the meeting, sir.
Okay.
You are in
So
the browser.
you can see me.
Yeah, good, sir.
Yeah.
Continue your meeting. Yeah, we just need to click on the website, ask them whether they can see your site, and you can continue from there.
Yeah. Can you see my share slides?
Yes, sir. Yes, sir. It is proper visible.
Sir, it is visible.
Okay. Okay. Then let me continue. Yeah. Okay. Thank you. Thank you. Yeah.
Thank you, sir. Thank you.
Okay. I'm so sorry for this delay and this all modern technology. I'm yet to catch up. So when I'm in my office, my engineers, they help me to solve all these problems. Okay. Anyway, let me start with apology once again. Yeah. So today, as I mentioned earlier, I'll be talking about where do we stand and how we can work together. Okay. So this presentation will be made by me, but as you see, they are my students. Hide this. Just give me a second. I hide this. Okay. And my students, Dr. Neo Kang Soon, he is a scientist in SimTech, and Afzal Ahmad is a associate professor in IT, Palakkad. Okay, so these contributions are mostly from them. They are currently working on machining as well as on 3D printing. So I borrowed a lot of slides from them and I tried to present. Okay, so let me move up. So, okay, the topic of today's seminar is 3D printing for biomedical application, shaping the future of healthcare. It's a very important topic, very relevant topic. I really admire and appreciate that you thought it, organized it, and you're sharing with everybody. Now, the question I asked myself, why I'm here, am I relevant? Because I told Professor Ravi many times that I'm a man of machining, why I should be talking about 3D printing. But he insisted. So I said, okay, I started thinking. I tried to find my relevance. And that relevance I'll be talking to you. My whole life, I tried to keep myself relevant. Because in this seminar, if I'm not relevant, I should not talk. So I found my way of relevance and I'll talk about it. So I'll share my own story. I'll try to not to go into more into details of research of 3D printing, but I'll try to tell that why machining should come in 3D printing. Does it have any role to play? Is it important role to play? Okay. So if you look at that point of view, I think I'll appreciate that, and you will also appreciate my presentation. Now, why and how? And why? Because when you do a 3D printing product, I'm not trying to undermine the product of 3D printing. It is very much necessary. As I mentioned earlier, 3D printing has opened up a new dimension in manufacturing. And I don't have to repeat it. Everybody accepts it. And initially, frankly speaking, I was thinking, why 3D printing in manufacturing? Is it not a ridiculous idea? And exactly same thing happened to me when I started doing research on micro machining and nano machining. I did a lot of research on myself, with myself, within myself. What is next for machining? Because manufacturing was so much dependent on machining, and it reached its peak or bottleneck that all machining were in macro level. Nobody thought of micro. When I coined this idea of micro, people ridiculed me and said, no, impossible. My first presentation was overseas in India. IIT, it's not IIT, Machine Tool Research Institute in Durgapur. And everybody says it's a buzzword, it will not survive. But I said, no, it will survive because it is necessary. And I then tried to justify it, saying how it is necessary. And then from there, I moved into ultra precision machining. And that also, I don't have to explain, people accept it, that it is necessary, because manufacturing from last century to this century had to move into a very new direction, new way, because not machining, it became micro machining, then nano machining, accuracy, absolute accuracy, dimensional accuracy, everything. So now, when 3D, and then again, the time became more and more final product you want to produce, time is getting longer and longer. And when 3D printing came in, many of the bottlenecks of machining have been removed, and it's a good thing. Some of the configurations we could not even manufacture using machining, and 3D printing helped us a lot. And so now 3D printing, I felt that it has come to a very high level, but a point is coming, or somebody might have already realized that it has a number of bottlenecks. And of these many bottlenecks, I'll touch on some of them only, is that accuracy. And moreover, you are talking about today for biomedical application. And as you know, biomedical application, no compromise is allowed. And you'll have to produce a product with absolute dimensional accuracy, best possible surface finish, and best possible material. So for that, I will try to tell you that application of ultra precision machining is very much needed, and it contributes a lot in 3D product to get the ultimate desired qualities of a 3D printing product. So those I'll try to justify. And again, I'm not trying to show my position that we are better, we are so and so not. Then I start with the thing that both need to work. 3D printing and ultra precision machining need to work hand in hand together, being a complementary to each other. Then definitely manufacturing will reach to another height where production will be faster, more accurate, more precise, and very much applicable for biomedical industries. Okay. You know, as I slightly touched on it, around 90s when I initiated micromachining, then in 2000 I started nanomachining. And now what we need to do, we need to break the barrier of poor finishing in 3D printing products. Time and is very fast, no doubt about it. So we need to start compound 3D printing and micro nano machining on the same setup, some basic conditions, same setup. That means machine setup should have something which can do, one side it can do 3D printing, and just putting that product on a pallet, it can be rotated on the other side, just rotated by 180 degrees. On the other side there will be another machine which can do precision machining. Or on the same machining, using a pallet, move the product from one left-hand side to right-hand side, and you do ultra precision machining. And benefit of that will be your duplication of resources will not be necessary. For instance, you prepare CAD data for 3D printing, and you convert the data into CAM machining, then same data can, just converting, you can use and do the machining. And more benefit of that is setup error will be zero. Otherwise, make a product in 3D printing, take it to a machining area, put it under machining center, then do machining, setup error will be huge. Whereas by rotating the pallet, you can have a very high dimensional quality product, setup error is 0. Moreover, investment will be low because you're saving space, saving investment, and ultimately you'll get a product which is much higher quality, better quality product. So those things I'll try to elaborate. When I'm saying that same machine but changing the palette, this palette concept is already existing. If you see a machining center, rotating the palette, as an example later, it comes with a lot of pallets and workpiece is set up previously. So just changing from right side to left side, the finished product goes out. The next product comes for machining. So this, I think I don't need to elaborate. Now coming to 3D printing for biomedical application, it's an example here. Many of the components of our bodies are currently made by 3D printing. 3D printing of skull, the scapula, this acetabular bone, and knee joint, jaws or tooth, and then sternum, and 3D printing of spine, 3D printing of osteotomy of the bones and so on. So there are many things, but if we do not machine them properly and put them on the body, they make biomedical, whether compatibility will be judged by the material scientist, but we'll have to make the product exactly to replicate the original component. There should not be any compromise. This example of a skull. And if you look at the hip joint, it's an example of hip joint. And hip joint is made up of titanium or nickel, very hard material. And if you look at the ball at the top, is very smooth and very fine, no compromise on surface finish. If you leave it, put it there as a 3D printed product, the life will be short. The patient will suffer when it wears off. So absolute care should be taken on finishing of it. So finishing of different ways of finishing, I'll be talking later. The finishing should be absolutely correct dimension, and which can only machining can offer that. Other technologies I'll compare and show to you. Jaws, tooth, again, same thing. Product must be of exact best possible accuracy dimensionally. Now, when you talk about accuracy, I just give an example of EDM. When you do machining by electrodischarge machining, this is a 50 micron hole, just as an example. Normal EDM will give a surface like this. If you look at, you cannot see actually with your naked eye, but when you see under high magnification, this is the picture. So that type of product cannot be allowed inside our body. The accuracy must be like this, as if it's a zig boring product. Okay, sorry. Something like this. So accuracy is so important. So today, very quickly, I'll go through this. These are the contents. Better additive manufacturing challenges and post-machining oblique finishing, nano-precision machining. And nano-precision machining can be done by various ways, like conventional ways, non-conventional ways. And then I'll touch on future direction and roadmap for advanced post-machining finishing of better additive products. Okay. Now, this is initially it is I thought of talking about additive manufacturing, different ways and so on. I think it will be irrelevant. I'm not in 3D printing. I'll be carrying coal to Newcastle. I'll skip them very quickly. These are all of you know about it. But when you produce a product of optics, like let us say the extreme example of telescope mirror. Telescope mirror, if you make it by 3D printing, these processes, finally the product, finally the product should be of absolutely optics quality, accuracy, surface finish, and mirror finish. And that finish of the surface should be in the order of nano. Previously, it was 6 to 8 nano. Then I'll give you the last example will be how accurate it should be, what we are expecting at the end of my presentation. And so this accuracy of the surface should be, currently we have reached up to 2 nano, and we are trying to go to 1 nano and below 1 nano. So that definitely needs
एफडीपी
machining.
खत्म हुई और एक चली आज से आपकी एफडीपी चल पड़ी हूँ सैटरडे संडे वाली.
Is anybody making any comment? Okay, so let me move on. And the automotive components, how they are manufactured and so on, I will not be talking about it. Aerospace one, everywhere it is there. I'll quickly. Now, challenges of additive manufacturing. Now, if you look at this very quickly, that also
ये 2 बजे वाला टाइम कौन रखता है?
And some of the defects or surface integrity suffers from boring defect, stair stepping, and first of all, it has some unmelted particles, balling, unmelted particles, and stair steps are there. So all these things cannot be accepted. They need to be removed, and that can be done by artificial machining. And cracks are there, higher roughness and cracks. So these should not be. These cracks, again, the problem of printing needs to take care. But roughness, definitely, roughness we can take care of it. Okay? So thereby we can improve the mechanical performance. If you look at when you do 3D printing, the temperature comes in and dimensional variation comes in. If you look at a product like this vertical and horizontal dimensions are not correct. So these need to be corrected. So this is again, this is micro cracks will be there because of heat is coming, heat is going, and so micro cracks should be avoided. Now, just a comparison of as cast or as 3D printed object. The accuracy usually in 3D printing, what we get is average surface roughness is 100 micron. And when you talk about other processes rather than machining, chemical polishing is 3.2 micron. And again, another for better chemical polishing is 3.2. Chemical polishing, it can try 1.6 micron. But if you look at machined component, normal machining component, it can give up to 0.8 micron. But if you go for advanced manufacturing machining, then we are talking about nano, 2 nano. We are not happy about it. We are talking about 0.4 nano. So that way, machining will be very much complementary to 3D printing to reach the desired quality of the product. Again, as you see, I discussed already that it reduces surface defect of the post-finishing can improve the surface quality of the product. And so, and that way, I mean, product quality can be much improved by machining. So today, so I'll be talking mostly on machining. I'll be comparing them with the grinding and polishing, blasting, shot pinning, mass finishing. So all these things ultimately, I don't elaborate on them. These are all mechanical processes, but ultimately you'll have to go through artificial machining. And chemical etching, chemical polishing, electro polishing is there. But all these polishing processes, in one sentence, I'll try to finish this. All this polishing process, please remember that absolute dimension cannot be achieved. The defined dimension, defined accuracy, defined dimension cannot be achieved because these are not direct contact process, indirect contact. And if the polishing pressure is definitely bound to vary, it will cause, if moreover polishing process is a soft pad comes in, so that you cannot guarantee applied force is constant. So deviation of surface form accuracy becomes spoiled. So you cannot, all the polishing processes should be avoided to get absolute dimensional accuracy. Yeah, so in general, I am always saying that polishing process is not suited for absolute finishing of nano dimension. Surface finish will improve, but definitely form accuracy will not be there. So to get the proper form accuracy, which is a must for optics. Yeah. Now, nano precision machining. So our target should be nano precision machining. Yeah. So I already showed that polishing, whatever you call it, laser polishing, chemical polishing, abrasive polishing, vibro polishing are done to improve the surface quality. Surface finish could be improved, but form accuracy cannot be much improved. So I skip that. For that, very quickly, just say that machines of ultra precision accuracy will be used. Machines, and just to give an example, this machine, which is of 8 pico resolution, these type of machine should be used. So I think I should not dwell on these things. And more details about all these white and so on. Surface integrity will improve. So if I talk about it, it will be long. Let me move on forward. And if you look at after machining, microtexturing of a finished product, you can get, this is the accuracy, which is absolutely high accuracy product you can achieve. So that way, then you can, here I think an important thing, again, I think I'm going into more deep into machining. I should try to avoid that. Just to show that if you do a cutting process, let me give you further quickly. Yeah. Where did I drop that slide? Cutting process, again, to get nano precision cutting, tool edge radius comes in. I think I will skip that. And yeah, this one. When you do machining, we are not absolutely perfect. When you do machining, the tool edge, we all think it is absolutely fine, absolute correct. It is not. It has some, at the cutting edge, it has edge radius, and which causes material to escape below the cutting edge. So that we need to take care very carefully, and we are almost there. So we can achieve, most likely, soon we will get about 0.8 nano surface finish. So these are also, I quickly skip. I think I have to spoil a lot of your time. These things also, by electro discharge machining and all these things are there. I think I should not elaborate on it. These are the only electro discharge machining. EDM machining can improve. And we have developed another process called EDM combined with ECM that gives absolute accuracy, very high accuracy. So these are, I think, you may not be interested in these things. I'll skip these as well. Yeah. So these case studies are, these are all very much on machining things. I should not bore you with this. I'll skip them quickly. Yeah, these are all 2 details of machining. Excuse me. If I talk about all these, I'll become very irrelevant. Now, let me quickly go through. If we combine this 3D printing with ultra precision machining, then ultimately we'll just give an example. If you look at this Hubble telescope, which saw the universe in 2002, this was a picture of the universe. When the Webb telescope came, 2022, this is the picture, which is 10 times better than the picture taken in 2012. So hopefully in 2032, using the technology of 3D printing combined with ultra precision machining, we'll see the universe 10 times better than what we saw in 2022. So that's all. I mean, now coming to this, I would like to say, if 3D printing research and ultra precision machining research, we do it hand in hand, then we'll achieve the target faster, more economic, much better, and so on. So let us work hand in hand together. Let us discuss the problems side by side, solve the problem together, being complementary to each other. Hopefully, we'll get much better product, much cheaper product, and much better quality products. So with that hope, I'd like to finish my presentation. Thank you so much. Yes.
Yeah. Thank you so much, sir, for this wonderful interaction with our participants over the various aspects of machining as well.
Yeah.
So dear participant, if you want to have, so if you have any query, any discussion to have with Professor Rahman sir, because Professor Rahman sir is a very well-renowned expert in the domain of manufacturing sciences, micro machining as well. So if you have any query, you can directly write your query in the chat box, or you can interact with him. Sir is ready for query.
Yeah, so you're always welcome, because if machining comes, sorry, yet I can't come out of this. So when it comes to machining, you're always welcome to discuss with me, and even anything, if it is on even 3D printing, which you expect to give a better surface finish, I'm always ready to discuss.
Yeah, please, sir. Any participant, please. Sir, someone has written in the chat box that software link to download or 3D model machine cost, something he just economical analysis he just want to have, I think.
I can't come out of the screen. Could you please read the question and I can try to answer?
Yeah, please, sir. He has written that software link. Is there any separate link so you can or 3D model machine cost? 3D.
No, I don't know. Is it to see all these slide details or what? I can share. Or what? I'm yet to get the question.
Yeah. See, K. Prasad, are you there? You can. Just a minute, sir. I'm connecting him. If he can directly ask his query.
Good morning, sir.
Yeah, good morning.
Sir, thank you very much for your nice presentation. Sir, myself, Binod Baroi. I'm PhD scholar from Jadavpur University. Actually, I am also working in the 3D printing for biomedical applications. Sir, my aim is to make a implant by magnesium. Actually, I want to replace the traditional implants such as steel and titanium. But sir, I'm getting some difficulties, as you know that magnesium is very much reactive. So directly 3D printing by FDM process is very much, I'm facing difficulty. So I have tried to make this product by gel printing kind of, means I am using magnesium powder to make it a gel and then I am printing it. So sir, can you elaborate something that how can I proceed on these things? And another second part that said this, as you mentioned, you worked on many things on micro machining, nano machining. Sir, can we do some surface modifications to improve the surface properties of these 3D printing products, such as we do some electrolysis coating, like nickel coating, to achieve our better surface properties such as surface roughness? Can you also integrate these things into 3D printed samples?
Okay,
Thank
let
you,
me
sir.
explain to you. If you use, that's why I was talking, when you try to do a secondary process. Like after 3D printing, you do coating or machining or whatever you do, you try to use on the same platform, because by rotating it from one side to the another, then you do not lose the data. So if your coating is what you machined, what you did the printing, you take the topography and then rotate it by 180 degrees to move it on the same platform. Then you do machining. Then you know that if your coating was whatever is 3 micron, so you'll have to machine it using the CAD data to produce into machining data. Okay, 3D printing data to machining data, and you can remove one layer or two layer or if you take the topography and what topography you want finally, and so you prepare your NC program, numerical control program, to machine that surface. Definitely you'll get a better product. Yeah. Now my question to you, not to encourage discourage you, is that why did you go to magnesium? Any reason? And why?
Yes, sir. Yes, sir. Actually,
Yeah.
I want to make some biodegradable implant that actually
Yeah.
dissolve in our human body without actually, if we use the permanent permanent implant like steel and titanium, to remove this implant we need a second surgery, sir. So if we can use some biodegradable and
Okay.
also biocompatible uh, implant, so we actually
Yeah.
do not need any second thing. So if we can control these degradations, that also acknowledging that the products that degrades are not affecting the human body or any is there where
Yeah.
it is implanted. So I am
Yeah.
trying to make such kind of things. But for magnesium, it is very much difficult itself to print it, means and
Okay.
if we want to go in the powder or gel form, to get a very nano form of its magnesium powder is also difficult, because in nano form magnesium sometimes can catch fire or get oxidized easily. So these things I am getting some difficulties. Sir, can you, sir, uh, give me some advice on these things?
Mm, as I'm not very familiar with 3D printing, I haven't put the right person to do that. But the concept is very interesting, very good. So try not to use coating, rather again on the implant you have produced. Try to do some secondary processes of finishing it. Whatever finishing you do, you'll have to choose which one you want to do, polishing or machining, though machining is best, but it has also its own limitation. If you do polishing, whichever by laser or by EDM, you can achieve that. So take care, good idea, biodegradable, but again, if you need to redo it, then take care whether a biodegradable quality is good enough to take it out without doing any damage to the base.
Yes, sir. Yes, sir.
So you'll have to take care of that. But to get the accuracy, that should not be a problem. There will always be a secondary process, which is not 3D printing, which should be some sort of polishing. Machining will be difficult because magnesium is very much, it generates heats when you machine it, and you cannot go to high temperature. So take care of that. So rather, I would say do some other processing, which again, a removal process should be smooth and cutting force should be as low as possible, because you cannot affect the tissues of the gum. So machining force should be as little as possible if you want to do after planting. If you do it outside, of course, you can do it easily.
Yes, sir. Thank you, sir.
So
Thank you so much.
yeah, welcome. Any other question? I don't know where from somebody.
Hello.
Yeah. Any other question?
Yes, sir. Good afternoon, sir.
Good afternoon.
This is Dr. A. Mutturaja, sir.
Yeah.
Actually, sir, regarding the adhesive machining system, I want to ask, sir.
Sorry?
Additive manufacturing, sir. AM.
Yes.
Yes, sir. Actually, sir, you have mentioned one slide, the
Yeah.
surface integrity issue, surface roughness issue. Actually, most of the time, whenever we go for AM, we are not able to get the expected surface roughness, sir. So we tried many times when my friend colleague was working in that field.
Yeah.
So we tried many times. We could not able to achieve it. Whatever we are expecting is the minimum roughness.
Yeah.
So can you suggest for
that
that,
is
sir?
what I'm trying to say. Have you finished your question? No?
Yes, I finished, sir.
Yeah, that is what I tried to say in my presentation. Biggest bottleneck of 3D printing is surface finish.
Yes, sir.
Because even if you use nanoparticles, particles will be added to another particle. So between these two particles, there will be not less than 1 nano, few nano error. For that, any 3D printed product will never achieve extreme high surface finish and quality. So you'll have to go for secondary processes, and that is machining, either polishing or machining. So you cannot avoid that. And if you can solve that problem, that will be a wonderful breakthrough for 3D printing. To my knowledge, till today, I have not come across with any 3D printing process which will guarantee a surface finish of 1 nano. And whereas in machining, our target is less than 1 nano. So that's why I'm stressing the point that we should work together. A 3D printing product should have a secondary process, which is machining or polishing, preferably machining. So don't try to break your head or break your bone. There could be some way, but so far nobody has been able to do it. And to me, theoretically, it looks almost impossible. But I don't say impossible. So keep that in mind. Try to achieve the best surface finish, best quality, but ultimate should be done by a secondary process, which is machining or polishing.
So actually, my question regarding this again, sir. Sorry, sir. Actually, sir, is there any international standard to achieve the product from AM, sir? Is there any international standards for surface?
No, don't go for that.
Okay,
It is international standard is standard based on what we have now.
Okay.
Best quality as available today. Our standard should be, it doesn't need research, because from the research they have got it. Research should be taking this current level to a higher level. When international standard is written, they try to take the best product in the market so that everybody can conform with that. But our researchers' duty is to take the product where it should be taken, where the user will take it, and they can claim that, yes, this is the best product. So that way, researchers should not look for international standard. Researchers should always look for a standard which will be the next international standard. Otherwise, if it is available in the market, such product is available, then what are we doing? We are not doing something new. We are doing something somebody has already done it. So don't look for international standard. Create your own standard so that the world follows you. Others follow you. Okay?
Thank you very much. Thank you very much.
You're welcome. Any other question?
Any other queries, please? So as the time is there, so we can have one more query only, so that then we can compile.
Yes. Sure, please.
So, one of the participant is asking from designer perspective, while implant designing, how much stock should be given in design for micro and nano finishing?
Okay. As I said, how much my expectation is up to surface accuracy of 1 nano, and preferably below 1 nano. Target should be there, and whether we can reach it or not, that is the challenge. And I'm hopeful it can be done, because in machining we have done it, and it is a 3D printed product. With the help and cooperation with a good machinist expert, it can be achieved. There we need to work together hand in hand.
नहीं join as guest बस.
Any question?
It was some disturbance from participant side. No issue. Now it is resolved, sir. Please. Okay, sir. So what I feel that most of the queries you have already discussed with our participants.
Yeah.
So we can compile our first session here. And we are really, really delighted and grateful to you, sir, for your valuable time in having discussing with our participant about the micro machining finishing methodologies, practices so far. And your insights are really very important and valuable for our participant. And I hope that they will definitely be benefited out of it. Thank you, sir. Thank you so much for being here with us.
Thank you. Thank you so much for listening.
Yes, sir.
And it was my
And
pleasure
it
to
was
present.
really, sir, very great thing, and we are highly thankful for you for just taking time out of your busy schedule and being here and to accept our invitation. We are highly delighted to have you here, sir. Thank you so much.
Yeah, thank you so much for, and excuse me for my inefficiency.
Yeah,
about,
no, so sir,
this
still,
technical-
these are the new tools, and you have done it so well. So that's good,
Yeah,
sir. Thank
first
you.
time I used WebEx, so
Yeah,
I got stuck.
yeah, definitely I can understand, sir. Thank you.
Yeah.
Yeah.
Thank you so much. Thank you.
See you, sir. Okay, thank you.
Thank you.
So, dear participants, the technical session first is now end up. I have shared the session 1 attendance link with you all, which is mandatory to mark. I have shared the link here at the WebEx chat box as well as on the YouTube chat. So, any way to which you are attending this session, so you will be able to just fill up that mark attendance using the link provided. Okay. In case of any difficulty, you can just directly write your queries or whatever here in the chat box. We will keep on sending these links session wise on WebEx chat box as well as in our YouTube chat box. Okay, so keep updating and be there so that you will be able to mark your attendance and attend the sessions conveniently. Thank you. So this is the end of our this particular first sessions. Second session we will have as per the schedule. It will be started at sharp 3 p.m. So our industry expert will be delivering his expertise over the topic. So see you there. So now you can just fill up the details and take a break. See you in the post lunch session. Thank you. If any query you can ask.
Hello. Sir, good afternoon, sir. Good afternoon, sir.
Yes, good afternoon.
Yes, sir. Actually, regarding this session, I want to know, sir. Actually, if I am using YouTube channel to watch these sessions,
yeah,
how I can? You are telling you will put the message that attendance details link in chat box.
Yeah.
But
Actually, number of time we will float at the end of this session. Every session we will float the link. Google Form link will be there.
okay.
So you can fill up the details. Whatever the session you have attended, you need to attend, mark your attendance so that on both the platforms, the attendance will be compiled at the end of this event. Okay. And
Okay.
accordingly,
So
your attendance will be provided over there.
Both place we have to complete the link or only one place?
No,
Actually,
no. Both on both the platform.
Both platform.
Yeah. We are having 13 session. For each and every session, we will float this form. Okay.
Okay.
For every session, you have to mark your attendance, and at the end, the test is very mandatory as per the AICTE ATAL guideline. So once everything will be fine, then you will be provided the certificate by ATAL Academy. Yeah.
Okay, sir. Another one doubt, sir. Do we have any WhatsApp group for this session, sir? FTP?
We have circulated, but not all the participants are there. That's why we are using these two platforms, means two chat box. That's why we are utilizing the chat box for circulating any information. Yes. Okay.
Hello. Hello, good afternoon, sir. I'm Dr. Ritu from Chandigarh University. Sir, I
Yes, ma'am,
request you
please.
to please share the attendance link on WhatsApp group also, because I am joining the session on YouTube. But I am facing some difficulty to mark the attendance through YouTube. So I request so please share the link on WhatsApp for attendance.
If possible, I am just sharing here in the chat box of WebEx you are attending from. No? If possible,
I am attending the session on YouTube. I'm attending the session on YouTube, but it's difficult to find out the link. So my humble request is if you share that link
on WhatsApp, it
our
will also
WhatsApp
be shared.
group.
No issue. On WhatsApp will be shared.
Okay.
No issue. Okay. But still we'll try
Okay,
to
thank you,
find the
thank
link
you, sir.
for
Thank you.
at least 10 times we will circulate. No issue.
Okay, thank you, sir. Thank you.
पच्चीस के 35